Okay, welcome back. Today we're going to look at section 5.3, which is on locating the real zeros of a polynomial function. So we're going to first look at what's called the rational root theorem, and then we're going to use that to help us find some roots and zeros of a polynomial. Now, the rational root theorem, in this day and age with the graphing calculator, we don't use it quite as much, but you are usually asked, and it's always questions on a test or the final, about finding these possible roots. So you do need to know how to do this, even though when we get into these later questions of this section, we're going to see that we don't really need this because we have a graphing calculator. So keep in mind that, these theorems were created way before calculators were invented, so these are the ways that we had to do things, before that happened. So why are we still teaching you? It's just a good thing to know. Sometimes, there's problems that'll come up, or maybe you don't have your calculator handy. So this is just one of the ways to help you solve these polynomials. So please remember that this is just the algebraic way to write a polynomial. So, this is what they're talking about. Polynomials are just a positive, the exponents are whole numbers. They go down in descending order, right? So this is telling you that if you have a polynomial and each coefficient is an integer, so they're numbers, okay, then we're going to take P over Q. And then we're going to take all the possibilities of P over Q, and those are going to give us possible zeros to the polynomial. So I'll explain that when we get to the picture or the problem in a minute. So I just want to remind you that P is always a factor of the last term. So P goes with the constant term. That's the last term in the problem. And Q always is the factors of the leading coefficient. Okay? So the problem that I see with this is sometimes because it says P over Q, a lot of students will do this number over this number, and that is incorrect. This is P, this is Q. So P is always here, Q is this number, okay? All right, so here's the thing. If I wanted to know what the zeros were, okay, and remember, what are zeros? It's where this graph will cross the x-axis, right? Well, if I don't have a calculator, how do I know where it crosses the x-axis? I have no way of knowing that without looking at the graph. So what this theorem does is it lists the possible numbers that it could be. So it takes away all of the other numbers out there that might be zeros and leaves us with only the ones that we need to check. Once we have a list of the possible ones, then we can quickly do synthetic division or divide them to see which one gives us a remainder of 0. Okay, what we learned in the last section. But again, because you have a calculator, this is going to be a very easy section, but you still have to be able to list the zeros, okay? So here's what we're going to do. We're going to list all of the factors of P and all of the factors of Q. All right, so remember, P is always the last term, Q is always the first term. So what are the factors of 10? And I'm going to list them in order. So we got 1 times 10 or 2 times 5. So I'm going to write 1, 2, 5, and 10. Okay? And then we're going to divide that by factors of 4. Doesn't matter that it's negative. Just what are the ways you can get 4 would be 1 times 4 and 2 times 2. So there's the only factors of Q. Now, when you list the possible factors, okay, it's plus or minus, and then we have to do every combination of these numbers divided by these numbers. So you can't miss any, so you just got to be careful. So the way that I do this is I take first the way, and again, you guys can do this any way you want to, but the way that I do it is I take each of the P's and then divide them by this first Q. So I'm going to do 1 divided by 1, 2 divided by 1, 5 divided by 1, 10 divided by 1. I just do this to help myself stay in order and not miss anything. So 1 divided by 1 is 1, 2 divided by 1 is 2, 5 divided by 1 is 5, 10 divided by 1 is 10. Okay, so got that out of the way. Now I'm going to take each of these numbers and divide by 2. 1 divided by 2, 2 divided by 2, 5 divided by 2, 10 divided by 2. And if you get a number that's already in your list, you don't need to write it down again. So 1 divided by 2 is 1/2. 2 divided by 2 is 1, and I already have that, so I don't need to write it down again. 5 divided by 2 is 5/2. And 10 divided by 2 is 5, which I already have. So I just got 2 more numbers out of that list. So I divided each of those by 2. And now I'm going to take each of these and divide by 4. Okay, so 1 divided by 4, 1/4. 2 divided by 4, which is 1/2, I already have it. 5 divided by 4, 5 fourths, 10 divided by 4, which will reduce to 5 halves, and I already have it. So there are all of the possible zeros for this function. So there's not another rational number that could be a 0. So instead of not having a clue where this thing crosses the x-axis, now I have a list of numbers that are reasonable for me to check. I still don't know which ones these are, but then what I would do is I would start with 1 and do synthetic division and see if I got a remainder of 0. If I do, then that's a 0. If I don't, then I would try -1. So you have to always put plus or minus because of all the positives and all the negative numbers. So this is really not 8 numbers, but 16 answers. So it's still a lot to check, but it's better than not having any idea whatsoever. Okay, so when you are asked to list the possible zeros, this is what you do. Now, from here on, if you're asked to list them to find the zeros, we're not going to really do that because we're going to use our calculators and we're going to find the zeros that way, okay? And that's what you're expected to do, but this is the steps on how you find them if you're asked. So you'll always see this list all the possible, you'll see that word. So that means they want the list of numbers, okay? All right. So let's look at actually what we're going to do. So example 2 says find the zeros. So we know already enough about, this graph. It's a 4th degree, so I know both ends are going to be up, right? Because the leading coefficient is positive. I know that at most I'm going to have 4 roots. I might have less than that because of the multiplicities. So I know a little bit about this. The one thing I don't know without my calculator is where do these cross, right? So I'd have to factor. Well, we don't know how to factor something with 5 terms in it, number 1. So what we would typically do is just do what we did. Find the list of possible rational zeros and then start dividing them to see which one gave me a remainder of 0. Well, we're not going to do that. So in these steps, okay, yes, we can use the degree to figure all that out, what I just said. We know that we will not get any more than 4 zeros. We might get less, okay? We're not going to really do this because we're going to just graph. So we're going to go to step 3 and say graph the polynomial, and then based on this, the graph and these numbers, so you can kind of do these in your head. Like I know I'm going to do 3 over 2, right? I'm going to do 1 over 2. So, we kind of have an idea of what numbers will be in there. But again, let's just graph it so you can kind of see what I'm talking about. So go to y equals. And we're going to put this in there. So 2x to the 4th plus x cubed minus 5x squared minus x plus 3. Okay? All right. And then we're going to graph this. All right. So I'm going to zoom in a little bit so we can see these numbers better. So I'm just going to hit zoom, and I'm going to hit number 2, zoom in, and then hit enter. All right, now I want to look at one that looks like it's going through a root. So this is not a whole number answer. So I'm going to start with -1. I don't know if that goes through 1 or not. It could go through 1. You could also go to your table to find out, right? But I'm just going to start with -1. Let's say I think that -1 is a 0. All right, I think that x equals -1 is a 0. Okay? So if it is, then I'm going to put -1 in the box, and I'm going to divide this out. Okay? Remember, I got to get a remainder of 0. So 2, 1, -5, -1, 3. Let's see if that's correct. So bring down the 2 and multiply. 2 times -1, -2, add that, we get -1. Multiply -1 times -1, that's 4. I'm sorry, that's 1. Add that, you get -4. Multiply -4 times -1, that's 4. That gives us 3. Multiply. All right. So that was a factor. So x plus 1 is a factor, right? All right. So now I've got this polynomial left over. This was x to the fourth. Now this will be x to the third, right? So 2x cubed minus x squared minus 4x plus 3. Right? Those are the coefficients of the remainder. All right, so I know now that is true. Okay, so now I have this polynomial, and I need to figure out if I have another root on there. Okay, so remember the graph. Next thing I thought might be true is 1. So now I'm going to take 1, so now I think x equals 1 is a 0. Okay, so I'm going to check that out. So I'm going to put 1, but now I'm going to divide it into this one. I already broke that down to here. I know -1 is 1. So now I'm going to use these coefficients, 2, -1, -4, 3. And I'm going to break that down. So bring down the 2. 2 times 1 is 2. Add that. 1 times 1. -3 times 1. So yes. Okay. So now I know that x minus 1 is a factor. Okay. So now look at what's left. Right? 1 degree less than this, so this will be 2x squared plus x minus 3. I know that's a factor, and remember the first one. Okay. All right, so now I'm down to something that I can factor. Okay, so let's see if we can factor that. I already got x minus 1, x plus 1. By the way, remember the graph? So this has to be x minus 1 squared, but let's just see what happens. Okay, so let's factor. So 2x times x. I need 3 in the middle. I'm sorry, I need 3 on the outside, 1 in the middle. So the 3 has to go here, the 1 has to go there. I need a positive x, so the 3x has to be positive. All right, so there we go. So we end up with 2x plus 3, x plus 1, x minus 1 squared. So remember, that's why it touched. So at 1, it touched -1. And then here's your other factor. So if you set that equal to 0, subtract the 3, divide by 2, we get -3/2. So right here at -3/2, that was our other 0. Okay? And so then now it matches kind of what we knew. This side started up, it crossed here. Okay, we know the y-intercept would be at 3, and then it touched there and went back up. Okay, so it matched what we've already learned about polynomials. Okay. All right, so we needed to find the zeros, right? That was the question. So just make sure you answer. So our zeros would be -3/2, -1, and 1. So I only got 3, even though this was x to the 4th. But remember, there really was a 4th 0 because this was a multiplicity of 2. Okay? All right. Let's look at another one then. Hopefully that helps with that one. All right, find the zeros. So again, you could use the rational roots theorem and find all of the possible zeros and go from there. But again, we have a calculator. So we are just going to put in x cubed minus 2x squared minus 14x minus 5. Okay, and we're going to graph it. I'm going to go back to the regular 10 by 10 window. Okay, so neither of these look like whole numbers. I always want to start with a whole number because that's easier. So I'm going to try 1, 2, 3, 5. I'm going to start with 5. I think that's a 0. These are going to be fractions, so I don't want to start with fractions. So I think that x equals 5. X equals 5 is a 0. thinking that, so I'm going to put 5 in the box, and I'm going to see if that's true. So 1, negative 2, negative 14, negative 5. See if we get a remainder of 0. So bring down the 1, multiply, add, multiply, add, multiply, add. So I do get that. All right, so that means x minus 5 is a factor. And then these are the coefficients of what are left. And we're going to start 1 degree less. So 1x squared plus 3x plus 1. Okay. All right. Now, this is not factorable. There's no factors of 1 that add up to give me 3. So that means that these guys are irrational roots. They're not fractions at all. They're going to be square root of something. So they're decimal numbers. Okay. So I'm going to do the quadratic formula to find my other zeros. Okay, so negative b, so negative 3 plus or minus b squared, so that would be 9 minus 4 times a times c, which are both 1, all over 2 times a, which is 1. So that gives me negative 3 plus or minus square root of 9 minus 4 times 1 times 1, that's 4. 9 minus 4 is 5 over 2. Okay? So that means I have 2 zeros here. So I know that 5 is a 0. Sorry for the dog barking. Okay? And then I'm going to break this up into the 2 zeros that it is. So we have negative 3 plus the square root of 5 over 2, and negative 3 minus the square root of 5 over 2. So, if you put this in your calculator, negative 3 plus the square root of 5 divided by 2, and negative 3 minus the square root of 5 over 2, you will get the same decimals as if you tried to find the roots using your calculator. Okay? So, you could give the decimal answers, but again, if you're asked to write it in exact form of the radical, then you need that. Okay? All right. Alrighty, let's try another one. So example 4 says you're given that x equals negative 1/2 is a solution. Let's find the remaining solutions and then write the polynomial in factored form. Okay? Alright, so again, I'm going to start by graphing this thing. Because again, you guys have your calculator. You know, you want to use it. It's here to help you. So if there's nothing that says we can't do this, I mean, that's what we would do. So 2x to the 4th minus x cubed. I'm sorry, I can't pause this thing, so otherwise I would. Plus 17x squared minus 9x minus 9. I'm sure she's not done barking yet. All right, let's graph. So we know that it's going to go through negative 1/2, right? So negative 1/2. All right, and it looks like the only other root I have is right here at 1, right? So let's start with 1, because again, I can't put a fraction in synthetic division. I would have to do this by long division, but let's talk about that first off. But x equals negative 1/2. If that's the root, then I need to set this side equal to 0. Remember, when you have a factor, you're not allowed to have fractions. So the first thing I would do is multiply the 2 over to this side. And then I would bring the 1 over. Okay, so this is a factor right there. 2x plus 1 is the factor that gives you a solution of negative 1/2. Because it says to write this polynomial in factored form. So I know I'm going to start with that. Okay. Problem is I can't do synthetic division. This is not in that right form. Now I could take this and do long division, but I don't want to do that if I don't have to. So it looks like it also goes through x equals 1, right? So let's try to put 1 in the box and see if that works. So use your coefficients. So 2, negative 1, 17, negative 9, negative 9. Let's hope that we get 0 remainder. So bring down the 2, multiply, add, multiply, add, multiply, add, multiply, add. Okay, so now I know that 1 is a factor. Okay, so x minus 1 is a factor. So now I know this. Okay. All right. And according to this, that is all that I had, right? So that means there's two other factors floating around over here that are not real numbers, but I still need to factor this down a little bit. So, all right, so let's see what I have. This is 2x to the third plus x plus x squared plus 18x plus 9. Right? So I'm taking those coefficients. That's what's left. All right, so now I can try to factor this by grouping. Because I can't divide this by 1. I would have to do this by the 1/2 or the 2x plus 1. Okay, so I think I can group this, and I'll see that that's going to be one of my factors. So let's factor that. So we can factor out an x squared. That leaves you 2 plus 2x plus 1. And then over here we're going to factor out a 9. That leaves you 2x plus 1. All right, so we end up with x squared plus 9. Group the numbers out front. And then remember, those have to be the same. Oh, so that gave me that factor, not that factor. Okay, so here's a factor, there's a factor. So I already have that one. So there's the other two. And those are definitely imaginary, right? Because you can't have -9. X squared can't equal -9. So there's the factored form. Okay. So you kind of have to, and I try not to give you too many of these, but anytime you see that it's only crossing the x-axis twice, and this is a 4th degree polynomial, hopefully you remember back in the day you guys did the imaginary roots as well, which would be these two. Okay, this would give you plus or minus 3i, if you remember taking the square root of -9, but we don't use imaginary numbers in this class. But so the factors are fine. I mean, that's fine, okay? But when you're given the zeros, you would say the zeros are just -1/2 and 1. Okay, because we're only looking for real zeros. Even though this accounts for four roots, they're not all real numbers. Okay. All right. Now, just so that you know, let's say you wanted to start and divide by this. Well, if that's the factor, again, you cannot put a fraction in this box. This has to be a whole number. It has to be in that form. So you would have had to have done long division with this and divided into that. I mean, and that's fine, but like I said, I rather not do long division when I don't have to, especially this one was a very long problem. So that's why I use my calculator, and thank goodness I found another easy number to do the synthetic division by. Once I got it down to x cubed, then I could factor that by grouping. So I didn't necessarily, I already knew the -1/2, but it showed up right here, and that's okay, because they already gave me that one in the problem. So really that's all that I needed, okay? All right, so hopefully that makes sense. All right, the last thing on here is what's called the intermediate value theorem, and that's kind of an older theorem. It makes perfect sense, but we don't use it a whole lot, again, because you have your calculators. All right, so it says, assume that f of x is a polynomial with real coefficients and a and b are real numbers such that a is less than b. If f of a and f of b, remember those are the y values, differ in signs, then there's at least one point C that would be between a and b where the y value of it would be 0. Okay, so that means there is at least 1 0 between a and b. And this is a very difficult way to just say something that is kind of very it's intuitive that you understand that. So let's say here is a, and f of a would be a negative number, right? F of a would be -3. And then we have over here f of b. Let's say f of b is right here. So if I asked you what's f of b, you'd say 1. Well, if f of a is a -3 and f of b is 1, then if I connect those two, what this whole thing is saying is that my line will have to go through the x-axis. And that's just common sense. If something's negative and you're going to something positive, then it's got to cross the x-axis. And where it crosses the x-axis is a 0. So if you're looking between 2 and 3 and the signs change, then somewhere between 2 and 3 will be a root. And that's what that's saying. Okay? All right. So let's look at that on here. It's a very simple process to do. Sound like we're hurting her. There's dogs going by, sorry. All right, so use the intermediate value theorem to show that there's a real 0 between 3 and 4. So all we have to do is show that these function values will have a different sign. So we're going to find f of 3 and we're going to find f of 4. And all you have to do is show that one of these answers is positive and one is negative. It doesn't even matter what they are, we just need to see what they are. So we're going to do this, okay, plug 3 in there, and see what you get. So I'll put that in the calculator. So 3 cubed is 27 minus 9 times 5 minus 24 minus 8. So we get negative 50. Okay? And then I'm going to do the same thing with 4. 4 cubed minus 5 times 4 squared plus 8 times 4 minus 8. So I'm going to put that in the calculator. So 4 cubed is 64 minus 5 times 16 plus 32 minus 8. And that gives me positive 8. So because there is a sign change, then I know there is a real 0 between 3 and 4. Okay? So again, it's helpful when you don't have a calculator, so that way you know, oh, well, I know my answer is going to be between here, but we have a calculator, so we'll actually see that it crosses there. So again, this is just the way that you would show that. All right, so the last one, we do the same thing. Find the values of at x equals 5 and 6, and then see if there's a real 0 between it. So we're going to find f of 5 and f of 6. So 5 cubed minus 4 times 5 squared minus 2 times 5 minus 5. Okay, so we're going to put that in first. So 125 minus 25 times 4 minus 2 times 5. All right, so that gives us 10. And then we're going to do the same thing at 6. So 6 cubed minus 4 times 6 squared, 2 times 6 minus 5. All right, so let's see what that one gives us. So 6 cubed minus 4 times 36 minus 12 minus 5. That gave us 55. Okay, so no sign change. So if there's no sign change, then there's no 0, no. Okay? So there's no 0 between 5 and 6. So again, you could graph that and you obviously would find where your zeros are, but we know that there won't be one between 5 and 6. Okay? All right, so that's the last thing, the intermediate value theorem. All right, so that does it for that section. So work on your homework, complete the notes, and then let me know if you guys have any questions.